Welcome. Today we're looking at the age of exploration, roughly the 1400s to the 1600s, an era that just fundamentally changed the world map, for better and, let's be honest, undeniably for worse.
Absolutely.
But what allowed European powers to suddenly, project influence thousands of miles away, across uncharted oceans?
It seems almost too simple, doesn't it?
It really does, and it comes down, in large part, to a seemingly simple object, the compass. And, well, the whole suite of technology that supported it.
Exactly.
So today we're doing a deep dive into the tech that enabled this huge global shift. We're looking at the motives, the means, and the immense and often quite horrific consequences of this time when small nations like Portugal and Spain suddenly started claiming entire continents.
It's really a fascinating story of technology meeting ambition. And, exploration didn't really start with these grand designs of empire building.
Yeah.
It began with something much more practical, almost mundane, the very high demand and high cost of exotic spices.
Right, the spice.
But that very quickly snowballed into national policy. Governments realized that the fastest way to extract wealth was through global colonization.
Okay, so to unpack this, we've pulled together research on navigation, both ancient and modern, and we've paired that with detailed historical sources. We're looking at the tech, the politics, the social impact.
The whole picture.
The whole picture. Our mission here is to show you how just a few nautical breakthroughs really unlock the entire planet, with all that entailed.
And where better to start than the motive?
Exactly. We have to talk about the incredible value of spice. If you really want to get your head around the age of exploration, you first have to understand why medieval Europeans treated, say, a handful of peppercorns like we might treat gold today.
That is absolutely the key context. The demand in Europe for pepper, cloves, nutmeg, cinnamon, it was just astronomical.
Well, not just for flavor, right?
Not primarily, no. I mean, flavor was part of it, sure. But these spices were absolutely essential for preserving food in an age before refrigeration.
Ah, preservation.
And also, frankly, for masking the taste of food that was, let's just say, past its prime.
Okay, right. And because they were so scarce, getting them to Europe was difficult. They weren't just flavorings, they became, like, actual currency.
They absolutely were. Our sources have some fantastic details here. Peppercorns, specifically, were so valuable that people routinely used them instead of coins.
No way.
Oh, yes. To pay fees, taxes, rent, even ransoms. Can you imagine paying off a major debt with a bag full of pepper?
That's incredible. But actually getting that pepper or those cloves to Europe was a massive headache for them.
Huge. Because of geography and because of who controlled the trade routes, the main supply, especially for the really valuable stuff like cloves and nutmeg, came from the Maluku Islands, the famous spice islands.
Which are part of modern Indonesia.
Correct. And for centuries, maybe from around 1100 to 1400, Arab traders had a near-total monopoly. They controlled all the overland and sea routes connecting Asia to the Mediterranean.
And they guarded that monopoly fiercely. It wasn't just about controlling the routes, was it? They used a bit of disinformation.
Oh, more than a bit. They were masters of propaganda. To discourage anyone, especially Europeans, from trying to find the source directly, they spread these wild, terrifying stories.
Like what?
We're talking mythical monsters, giant flesh-eating birds guarding the islands, just completely fantastical tales designed to scare off any potential competitors.
Wow.
And you know what? It worked. For centuries, it helped preserve their trade advantage.
So this helps explain why accounts like Marco Polo's from the 13th century, detailing all the riches he saw in Asia, why they were so incredibly influential even years later.
Exactly. For ambitious rulers and explorers, people like Columbus, the goal became really simple.
Cut out the middleman.
Cut out the Arab middlemen entirely, find an all-water route to the east.
But desire isn't enough. You need the means. You need the technology.
Precisely. No amount of wanting spices could get a ship across the Atlantic and back safely. You needed the right tools, the right nautical inventions, and, rather fortunately for the Europeans, several key pieces of technology sort of came together around the same time, in the mid-15th century.
Okay, so what were they? First, you need a better boat, presumably.
You definitely need a better boat. Crossing huge oceans demanded something that could handle really rough seas but also be maneuverable enough to explore coastlines and, crucially, sail effectively.
And that's the caravel.
That's the genius of the caravel. It was a real hybrid. It took the best bits from different shipbuilding traditions. It had the fixed, strong hulls and the big square sails common on northern European ships. Great for stability in storms.
Okay.
But the real game changer was adding the triangular lateen sails, which were more common in the Mediterranean.
The triangular ones, why were they so important?
Because they allowed the ship to do something previous European ocean-going vessels really struggled with. They could sail efficiently into the wind, or at least much closer to the wind.
Ah, so they weren't just stuck going wherever the wind blew them.
Exactly. They could actually navigate against prevailing winds and currents to some extent. They could plot more difficult courses, explore more freely. It opened up possibilities that just weren't there before.
Okay, so you've got the ship. Now you're out in the middle of the ocean, miles from land. How do you know where you are? No landmarks.
That's the next crucial piece. Celestial navigation. You needed tools to figure out your position using the sun and stars.
The astrolabe and the sextant.
Primarily, yes. The astrolabe was earlier, the sextant came later and was more accurate. These were absolutely essential for determining latitude, your position north or south of the equator.
How does that work, though? How does measuring the sun's height tell you your latitude?
It's based on geometry, essentially. The height of the sun at noon, or the angle of certain stars above the horizon, changes depending on how far north or south you are. So, by measuring that angle accurately and knowing the date, which tells you the sun's expected path, you can calculate your latitude. These tools gave them fixed reference points in the sky, which was the only reliable way to plot a north-south course across a featureless ocean.
Okay, so that handles latitude. What about just keeping track of time and speed? You need that too, right? For estimating distance travel.
Absolutely. And for that, they relied on some fairly low-tech but vital tools. Timekeeping depended heavily on hourglasses.
Zan timers.
Yep, usually turned every half hour. They used them to track the duration of shifts or watches aboard the ship. Speed was measured using a log line.
The thing with the knots.
Exactly.
Yeah.
A piece of wood, the log, was thrown overboard attached to a rope with knots tied at regular intervals. They'd let the rope run out for a specific time, measured by a smaller sand glass, and then count how many knots had passed through the sailor's hand.
And that's literally why we still measure ship speed in knots today.
That's precisely where the term comes from. Simple, but effective for estimating distance covered over time, what sailors call dead reckoning.
All right, let's get to the star of our show, so to speak. The compass. Magnetic compass, which was actually a Chinese invention,
That's right.
was the main tool Europeans used for figuring out their direction at any given moment. North, south, east, west.
But just relying on that magnetic needle had one massive built-in problem. A liability, really.
The fundamental problem is that the magnetic compass, well, it lies. Not intentionally, of course.
Right.
But it doesn't point to true geographic north, the North Pole on the map. It points to the magnetic North Pole.
But the Earth's magnetic field isn't stable.
Not at all. It's constantly shifting, it's dynamic. The magnetic North Pole itself actually wanders around.
And this isn't just some abstract geological thing. It moves significantly.
Absolutely. Get this. The magnetic North Pole has drifted more than 600 miles just since the early 19th century.
And it's still moving. Right now, it's shifting about 40 miles every year. So imagine being a navigator in the 15th or 16th century, relying on this thing. You're constantly dealing with this magnetic variation, the difference between true north and magnetic north, which changes depending on where you are and when you are there.
That's mind-boggling.
And to give you an idea of the long-term scale of this instability, if you go way back, about 800,000 years ago, the Earth's magnetic field actually flipped entirely, a full pole swap.
So a compass pointing north back then would have actually pointed towards Antarctica.
Pretty much, yeah. Now, historical mariners only had to deal with the smaller shifts, the variation and also deviation caused by iron on the ship itself. But the core point is, the needle they relied on so heavily was always fundamentally inaccurate compared to their maps of true north.
Which makes tools like the astrolabe even more critical.
Exactly. They weren't optional backups. They were mandatory for correcting the compass's inherent errors, especially for determining latitude accurately.
it really makes the achievements of those early explorers even more impressive, navigating with a tool that was constantly, misleading them.
It forced an incredible reliance on careful astronomical observation, detailed mathematical corrections, updating charts. It was complex work.
But it's fascinating, isn't it, that while Europeans were grappling with these metal instruments, other cultures navigated vast oceans using completely different methods.
That's a great point. You look at the Polynesians, for instance. They didn't need magnets.
No.
They developed these incredibly sophisticated systems based on observing star patterns, swell patterns in the ocean, wind directions, bird migrations. They navigated the enormous Pacific Ocean for at least 2,000 years using this deep environmental knowledge.
And they formalized this, didn't they, into things like the Hawaiian star compass.
Yes, relatively recently, in the mid-20th century, they sort of codified this ancient knowledge into structures like the star compass. It often looks like a 32-point magnetic compass rose, but the points refer to the rising and setting positions of specific stars or wind directions, not magnetism.
It's a powerful reminder that deep observation of the natural world provided solutions that were, in some ways, more reliable than relying on a wobbly magnet.
Absolutely. And even today, there are non-magnetic compasses. Modern ships and aircraft often use gyro compasses.
How do they work?
They use a fast-spinning gyroscope. Its axis maintains a fixed orientation relative to space, and through some clever mechanics, it can be made to align with the Earth's actual axis of rotation. So it points to true north, eliminating all the magnetic variation issues.
Okay. And there were others too. Solar compasses?
Yes, solar compasses use the sun's shadow angle, particularly useful near the poles where magnetic compasses become very unreliable because the magnetic field lines are pointing almost straight down.
And just for fun, there's even the old analog watch trick for finding direction, right?
Well, yeah, the survival trick. Point the 12 o'clock mark at the sun, and roughly halfway between the hour hand and the 12 is your north-south line. North is the direction further from the sun in the northern hemisphere. Not precise, but better than nothing.
Okay, so from stars and sunglasses to GPS. Let's make that jump. Today, the ultimate navigational tool seems to be the GPS receiver in our phones or cars.
It really is the peak of this technological journey, in a way. GPS receivers talk to a whole network of orbiting satellites and ground monitoring stations.
And they tell you exactly where you are.
Latitude, longitude, even altitude, yeah. With incredible precision. Standard commercial GPS, what's in your phone, is usually accurate to within about 6 meters, maybe 20 feet.
Which is already amazing.
But then you have advanced systems, sometimes called super GPS or differential GPS, used in surveying or construction. Those can pinpoint a location down to within 10 centimeters.
10 centimeters. That's
100 inches.
It's staggering. Compare that to the 15th century, where finding your latitude within, say, half a degree, about 30 nautical miles, was considered a major navigational success. And this modern, almost godlike ability to know exactly where we are anywhere on the globe. That's precisely the kind of capability, albeit much rougher, that those first European explorers were striving for with their astrolabes and their unreliable compasses.
Exactly. And once they had the means, the caravels, the astrolabes, the compasses, however imperfect, they really started to aggressively pursue their motives. Which leads us directly to the age of empire building and, tragically, exploitation.
Portugal really led the charge initially, didn't they? Pushing eastwards.
They did. Heavily sponsored by Prince Henry the Navigator. Their goal was that sea route around Africa to Asia. Bartolomé Dias made a huge breakthrough in 1488 when he rounded the southern tip of Africa.
What they first called the Cape of Storms.
Yes, later renamed the Cape of Good Hope, maybe for better PR. That voyage paved the final leg for Vasco da Gama, who successfully reached India by sea between 1497 and 1499. That shattered the centuries-old Arab-Venetian monopoly on the spice trade.
And Portugal also ended up claiming Brazil, almost by accident.
Almost. In 1500, Pedro Cabral was leading another expedition to India. To avoid the difficult currents and calms in the Gulf of Guinea, he swung way out west into the Atlantic.
And bumped into South America.
And bumped into the coast of Brazil, claiming it for Portugal under the terms of a treaty we'll get to in a second.
Okay, so while Portugal was going east, Spain was betting on going west.
Enter Christopher Columbus. He was convinced the world was much smaller than it actually is, and that sailing west would be a relatively quick shortcut to the East Indies.
Famously wrong about that.
Famously wrong. And our sources mention something interesting. He apparently kept 2 different ships' logs during his 1492 voyage.
2 logs. Why?
One accurate one for himself, and another one that deliberately understated the distance traveled each day. He showed the fake log to the crew.
To stop them panicking.
To prevent mutiny, basically. When the voyage took much, much longer than he'd promised, showing them a log with shorter distances helped keep their hopes up, or at least delayed their despair.
And when he finally made landfall in the Caribbean, he thought he was where?
He was convinced he'd reached the islands off the coast of Asia, the East Indies, which is why he called the indigenous Taino people he encountered Indians, a misnomer that stuck for centuries.
So now you have Spain claiming lands to the west, Portugal claiming lands to the east. This must have caused friction pretty quickly.
Immediately. A major geopolitical crisis for the 2 main Catholic seafaring powers. How do you divide up the entire unknown, non-Christian world?
With a treaty, apparently.
With the Treaty of Tordesillas in 1494, Pope Alexander VI basically brokered a deal. They drew an imaginary line down the Atlantic, 370 leagues west of the Cape Verde Islands.
Just drew a line on the map?
Pretty much. Everything discovered west of that line would belong to Spain, and everything east would belong to Portugal. It's why Brazil, which juts out east of that line, ended up Portuguese, while most of the rest of the Americas became Spanish claims.
It's really chilling when you think about it. These incredible breakthroughs in navigation, these triumphs of human ingenuity and endurance, directly enabled the claiming and dividing up of entire continents and populations, often with devastating consequences.
The human cost cannot be overstated. Take Ferdinand Magellan's expedition. His crew, well, what was left of them, led by Juan Sebastian del Cano after Magellan was killed, achieved the first circumnavigation of the globe between 1519 and 1522.
An absolutely monumental feat of sailing.
Monumental, but also a profound human tragedy. Magellan himself died in a skirmish in the Philippines. They started with 5 ships and about 270 men.
And how many returned?
Just one ship, the Victoria, limped back to Spain in 1522, on board. Only 18 of the original crew.
18 survivors out of 270.
And this shows the cold calculus of the era that single surviving ship was still packed with valuable spices, mostly cloves from the Spice Islands.
Enough to cover the cost.
Enough spice cargo that its sail more than paid for the entire disastrous 4-year expedition. The profit motive was just that strong. The risk, even that level of risk, was deemed acceptable.
And while Magellan's crew was sailing around the world, Spain was consolidating its hold on the Americas through the conquistadors.
Yes, figures like Hernán Cortés, who conquered the Aztec Empire in Mexico, and Francisco Pizarro, who took down the Inca Empire in Peru. They overthrew huge, established civilizations with relatively small forces.
How? Was it just superior weaponry?
Weaponry played a role. Sure, steel swords, armor, horses, cannons were terrifying. But the single biggest factor, the deadliest weapon the Europeans brought, was unintentional.
Disease.
Disease, smallpox, measles, influenza, viruses to which the indigenous populations of the Americas had absolutely no prior exposure and therefore no immunity.
The impact was catastrophic.
Devastating doesn't even begin to cover it. We have figures suggesting the indigenous population of Hispaniola, the first major Spanish settlement, dropped from potentially 1 million people in 1492 to only around 500 just 50 years later.
1 million to 500 in 50 years.
That level of depopulation happened across the Americas. It was a demographic collapse on an unimaginable scale, mostly due to disease.
And this collapse created a massive labor shortage for the Spanish, particularly in mines and on plantations.
Especially sugar plantations. Sugar was becoming a hugely profitable cash crop. The Spanish had initially implemented the encomienda system.
What was that?
It was basically a grant of indigenous labor. Spanish colonists were given the right to demand tribute and forced labor from the local inhabitants in exchange for, supposedly, protecting them and instructing them in Christianity. In reality, it was often brutal exploitation bordering on slavery.
But when the indigenous population collapsed from disease,
the source of labor disappeared. And to fill that gap, particularly for the incredibly harsh work on sugar plantations, the Spanish and Portuguese began importing enslaved labor from Africa in massive numbers.
Which formalized the horrific system we know as the triangular trade.
Exactly, a brutal cycle connecting 3 continents. Europe would send manufactured goods, guns, textiles, alcohol to Africa.
Where they were traded for people.
Traded for enslaved Africans, often captured in wars fueled by the demand for slaves or kidnapped. They were forcibly marched to coastal fortresses like Elmina on the Gold Coast, the so-called Slave Coast.
And from there, the Middle Passage.
From there, they were packed onto ships for the horrific journey across the Atlantic to the Americas, the Middle Passage. They were treated purely as cargo, not as human beings.
The conditions are just inhuman.
Unimaginably brutal. Sources describe people chained together, packed into tiny spaces below deck, often just 6 feet long and maybe 16 inches wide per person. Disease, malnutrition, dehydration, abuse were rampant.
What was the mortality rate?
On average, historians estimate about 15% of enslaved people died during the Middle Passage. 15%. On millions transported over centuries.
And they arrived in the Americas to be sold into forced labor, primarily producing the cash crops, sugar, tobacco, cotton, that were then shipped back to Europe, completing the triangle.
Generating immense wealth for European merchants, planters, and nations built entirely on stolen lives and forced labor.
So it really brings us full circle, doesn't it? The age of exploration, powered by this burst of technological ingenuity, the caravel, the astrolabe, the compass.
Tools that provided the means to explore, to find new routes, break trade monopolies, seek riches.
Yes, but that very same technology, that ability to cross oceans and project power, also directly facilitated global conquest, mass exploitation, the horrors of slavery, and the brutal Middle Passage.
Absolutely. The ability of European powers to travel to, control, and extract resources from distant lands fundamentally shifted the global balance of power. Naval dominance became key. You see it clearly, for instance, when England defeated the huge Spanish Armada in 1588. That really signaled a shift in who controlled the seas, built on these very navigational and shipbuilding breakthroughs.
It's a profound legacy. Ingenuity and tragedy intertwined.
Deeply.
So leave you with a final thought. We know the Earth's magnetic poles are still shifting, still wandering, just like they were for Columbus and Magellan.
They are indeed.
And we know our modern, hyper-accurate GPS systems rely on complex and potentially vulnerable external infrastructure satellites, ground stations. So how much should we today, whether as modern explorers or even for critical infrastructure, still rely on those centuries-old robust technologies like the simple magnetic compass? And maybe more importantly, what happens to our interconnected world if that simple foundational technology or its modern equivalent unexpectedly fails?
That's a really crucial question for our times. How resilient are our systems, really?
Something to think about.